Hi, my name is Nicholas Fry, and today I'm going to talk a little bit about PlaneSense. We did this project with myself, DJ Myers, Tarek Amami, and Matthew Bragg. So, to talk about what we completed, from Stratix, we should be able to identify nearby planes based off a distance oriented minimum priority queue. The idea would be is to take the closest plane and use that based off our location, grab the azimuth, elevation, and distance from our current location to the plane, and play it through 3D audio. Like create the like a vector to kind of tell you where you're at compared to them, and you should be able to hear it. Anyways, unfortunately, the 3D audio of Golang wasn't as easy as we thought it would be, and we wrote a library of functions to attempt to play the sound. However, we failed to implement the functionality so far. So in the meantime, we're actually simulating 3D audio by defaulting to play pre-recorded thresholding sounds. Again, this is calculated from the azimuth, elevation, and distance, which works, and we use this to simulate 3D audio. The kind of part that we're stuck at is we have the HRIR array, but we're failing to convolve the sound based off the sound byte array from Golang, the SOX library. So what's next? Well, one of our ideas we had was if you could figure out how to implement 3D audio in the language of your choice, let's say Java for this example, you could almost create like a socket-based implementation that will take in like coordinates such as azimuth, distance, and elevation, and the HRTF of your choice. You could post over your sound file, and maybe we can make a back-end sound generation engine. And this way, you're language agnostic. You could use this for any application you want to make 3D audio for, and it'll work. And what this will allow us to do, if we had to do this in the future looking forward, is this will allow us to ignore the language/library specific problems we've encountered and focus on implementing this approach, in our case with Stratix. In your case, it could be with anything else. I mean, how cool would it be to have a 3D audio as a service company and charge people per sound byte that they convolve and sell to them? This might be the next Salesforce or Facebook, so look out. That's what we're aiming for. So I'm going to hand this over to Tarek, and he's going to talk about the potential clients that we could have.
So with this product working like how we want it to, the potential clients include hobbyists, commercial pilots, aviation headset companies, ADSB device companies, and major transportation airlines. So as a hobbyist like myself, we would be able to lessen the workload in the cockpit and increase safety. And this creates an ease of mind for the pilot so he can focus on other tasks in the cockpit. The same goes for commercial pilots. Headset companies like Bose and Lightspeed would actually be able to use our software in their headsets to maximize safety for all pilots at a minimal cost. ADSB companies such as Stratus would be able to use this code to feed audio into a headset as well. Lastly, major airlines can implement this software as a safety standard across all regional and international flights at low cost to increase safety and decrease workload in the cockpit. We can also add this to existing systems. Currently, we can add this to Stratix, the current open source project. The other existing systems that PlaneSense can be implemented through are any Garmin solutions, one of which is the G1000, the dual glass cockpit solution for aircrafts. This has traffic information built in. The audio would actually already feed into the headset, so the software would just need to be implemented with the G1000. This software, however, is not open source, so Garmin must implement our solution as a competitor to Stratix. There are also other airline navigation and traffic systems, but the main ones are G1000, Stratix, and Stratus. I'm going to hand this back over to Nicholas for the future steps.
So again, for future steps, I mentioned this earlier, but we really want to, maybe spin off a project where we could create a 3D audio-based engine, like an implementation engine that's HTTP based. So this way you decouple the 3D audio from the actual device you're trying to implement it with. And what's nice about this is if something like this existed, Imagine how much easier, yes, I'm talking to you, the audience, how much easier your project would be if you could just post over coordinates of where you need the sound to come from and post over the sound file and, select something like Keymar 1, Keymar 2, whatever. With something like this, I mean, again, the sky's the limit. Look at Microsoft in terms of their Xbox One. To my understanding, a lot of their computation is done on Microsoft Azure, and they actually send it back to the Xbox, so that's how they jokingly beat PlayStation, but the sales say otherwise. Anyways, 3D audio as a service, I personally see as a possible venture out of this project, and it would more be along the lines of, hey, this is what we wish we had, and this spun off a difficulty, and hopefully it could save you guys a lot of time. Additional functionality, if we had infinite time and resources, would be to rewrite Stratix from the ground up using any language but Go. Go is a very nice language implemented by Google. Sorry, Google. But it's not a practical language because doing multiplication between like a float and an int, you would imagine would be easy, but believe me when I say it's not, because you have to cast every single thing to be in the same type. Very annoying. I'd rather use C and then, tie the C language to something else, but Go has to go. Another thing we'd like to do is have a sound selector, so you'd be able to choose the kind of sound we have. So from our survey we did earlier this semester, we found that a lot of pilots want simply a beeping sound to come in the direction another plane is at. For the sake of our project, we did an engine noise because it was just, I don't know, we already had the sound file. For us, it sounded more realistic, but in real life, it would probably be better to do beeping. And we'd probably like to implement more than 9 positions in 10 sounds. 9 positions meaning because we're using a thresholding-based sound system where your coordinates are at to simulate 3D sound. And we'd also like to add multiple HRTFs and an HRTF selector to the web UI for Stratix. This way, for someone like me where Keymar 1 works and someone like Tarek who, which one did you use? I think you used like Keymar 2, right? Or another one. Either way, you give someone a preference so they'd be able to use this more practically. So to talk about a description of challenges, we learned a lot in class. We learned how to take an HRTF, we learned about convolving, and we learned about how to apply it to the 2 channels of audio. However, we found it extremely difficult to actually implement this in code, especially with Golang, and most of our issues kind of came around the revolver. Another big challenge we're facing right now is that Golang has a very steep learning curve. Some of the specific issues which I brought up earlier was something as simple as like multiplying an int in a float 64. The program would say, hey, you're trying to multiply 2 unlike types. Even printing, like if you're trying to print or concatenate a string with like an int, it was a pain in the neck. So, we had to do casting, and casting got very annoying. We tried pair programming, but the thing is, since we were all on the same page, it helped, but there's still a lot of difficulties. So anyways, thank you for your time. We appreciate you listening to this, and we hope you have a great day. Bye-bye.